All right, this problem, they want us to find all the values of theta. So that's talking about an angle between 0 and 2 pi. So we're looking at radians here. And they want to find the angle where cosine of that angle is equal to square root 3 over 2. Now, even though this is in radians, I'm going to do this in degrees first because I think a lot of you are more comfortable with degrees. So on your calculator, if you're doing that in degrees, go to mode and change it to degrees here. Um, so a way we can do this is if we know the cosine of that angle square root of 3 over 2, we can search out that angle by moving the cosine to the other side where it becomes inverse cosine of square root of 3 over 2. And this should tell us one of the possible angles that will make this true. So on the calculator, how you do that is hit second cosine to do inverse, and then type in square root 3 over 2. Make sure you close the parentheses after the square root. And if we hit enter, it'll tell you the angle. Now, I did it in degrees, remember, so this is telling us that one possible angle here is 30 degrees. Okay, so on the unit circle, where 30 degrees is, that location should it give us one of our coordinates here should be square root of 3 over 2. Now, one thing you need to remember is which one is cosine going to give us? Is cosine our x value or our y value? Well, whenever you do an ordered pair on the unit circle, that's always your x value. And the reason, again, x value is going to give us, if we make that right triangle, x value is going to give us that side because cosine uses adjacent over hypotenuse. That's our adjacent side. That's our x value there. So we want to use cosine. So this tells us here that this x value here is going to be square root 3 over 2. We don't really care what that y value is, but we know that that x value is there. Okay, so the other thing we got to worry about now is there another one? Well, yeah, there should be another x value here that also gives us square root of 3 over 2. If I follow this down, there's going to be another point right there whose ordered pair is also square root 3 over 2. And again, I don't care what that y value is. It's going to end up being negative where this one's positive up here. But we know there's another place on this circle that has that. What is that other location? Well, the other location should have the same x value, just different y value, and it should be the same amount, meaning if I make the triangle here, this would also have to be a 30-degree angle. But that's 30 degrees going back the other way, whereas this is positive 30 degrees, this would be going opposite direction, so that's negative 30 degrees. So what is negative 30 degrees the same as? Well, the easy way to figure that out, remember it going all the way around the circle is 360. So if we take 360 degrees, subtract 30 degrees, we'd end up with 330 degrees. So our second answer, the other location that gives us a value of square root of 3 over 2 would also be 330. And just to show you, if you go on your calculator and go cosine 330, it should give us square root of 3 over 2. Remember, that's our approximation for square root of 3 over 2. Okay, last thing though. Remember our problem said between 0 and 2 pi. That's in radians. If they're looking for an answer in radians, we need to now convert these to radians. They're not. So how you do that? Use our conversion factor here again. You can multiply 30 by pi over 180. And same with this one, multiply 330 by pi over 180. If you simplify those down, that would give you the equivalent. Easy way to do it on the calculator is leave the pi out and just simplify the fraction. For example, 30 over 180 as a fraction. That one's pretty easy, is 1/6. So if you put the pi back in there, that's pi over 6. You could do the same thing with the 331, 330 over 180. is 11 pi over 6. So those would be our two locations there in radians. Where if we take the cosine of those two in radians, it should give us square root of 3 over 2. You could do the same problem in radians. I just want to show you that quick for those of you who might like that better. So if we did inverse cosine, like we did in this step right here, inverse cosine of square root 3, close it up again, over 2. Now you get this. Now that's kind of a garbage type decimal that we're not really familiar with. But you got to remember here, what's in this answer if it's in radians? There's a pi in there. So what you'd have to do on your calculator if you want this as a fraction then is to divide out that pi. So if I hit divide that answer divided by pi, now you see something. Okay, that fraction's looking a little bit better if I see what that is, a fraction of 1/6. And so if I put the pi back in there, what answer do I get? Pi over 6. And then you'd again have to figure out what that second angle would be from that. All right, I want you to pause the video and see if you can find the angle or angles between 0 and 2 pi for this one. All right, let's check and see what you got. If we do inverse here of sine, and remember this is talking about a y value now of negative square root of 2 over 2. Let's see what we get here. I'm going to go back to 100 degrees here. So inverse sine of negative square root of 2, close that up over 2, and we get negative 45 degrees. So that's telling us one of our angles here is negative 45. Now, while you were doing this problem, hopefully you notice that we need to be between 0 and 2 pi, or the 0 and 360. That angle is not. And so the easy way of figuring out that equivalent angle between 0 and 360 is to add 360 to it. So if we added 360 to this, that's now giving us the angle of 315 degrees. So that's one answer. Is there another one? So on a unit circle, okay, negative 45 or 315 degrees, that's going to be right here because we moved back 45 degrees. Okay, is there another angle that has the same y coordinate of negative square root of 2 over 2? Because remember, sine is your y value when you have an ordered pair. Well, yeah, there should be another one over here. Which ordered pair is going to have that same y value? If we follow it across, this angle here should, this one right here should have the same y value of negative square root of 2 over 2, just like this point had over here. Well, what angle is going to have to give us that? That means this angle right here should also be 45 degrees, just like this angle was 45 degrees. How do we figure out that second angle? Well, you stick with what you know. How far is this? That's 180. And we're going another 45 there. So what's 180 plus 45? 225. An angle of 225 should also give us that same value. Just as a way to check, if you do sine 225, there's negative square root of 2 over 2. Remember, that's our approximation. That's our two answers in degrees. Again, though, you got to convert them over. So if we did 225 over 180, because our conversion's pi over 180, and we see what this is as a fraction. One answer we get here is that this one's 5 pi over 4. Do the same thing with 315. And you can convert that. That's 7 pi over 4, so our two answers, or the two answers you should have gotten, are as follows.